Welcome to Old Iron Machine Works. I appreciate you stopping by to check out the video. Let me start by thanking my new subscribers. I really appreciate it very much. In this video, I will be repairing a cutter head on a 1951 Northfield Jointer. I normally don't like longer videos. I was trying to decide if I wanted to split this one in two or not. I decided to do one longer video. What it is this joiner belongs to a friend of mine, and when he would run it, it would want to walk across the room, and it definitely had a bent shaft. And right here, I'm got it in the lathe and just doing some dial indicating, trying to narrow down exactly where the bend is. This is a direct drive, which means that the rotor for the motor is attached right to the shaft. And at some point, the joiner did fall over, and you could see some welds on the end bells of the motor where somebody's had to weld them back up. So I decided to take this on. I've had it for quite a while. It took me a while to get to it. Took it on more of a challenge and to help a buddy out. Here it's showing, you can see the run out. Of course the bearing's running nice and true, but when you spin the whole shaft, it clearly bent. Right here, that's the retainer that holds the bearing in the main cutter head locked securely. And then of course right there, that's the rotor for the motor. It's just pressed onto the shaft. And you can see here where it's bent up pretty good. That whole end took a shot and it bent and tweaked. It's pretty obvious in the video, and that all needs to be straightened out. Here you can see the end was machined, and it has the little shoulder there, and it had a little small thin plate that just attached with 3 screws. Later I'll make a little slug that'll attach in there, so when I straighten it, it'll kind of hold that shape and not tweak it all up. Here I'm pulling the rotor off of the shaft. The only thing that holds it on the shaft is a press fit, and it does have a keyway. Other than that, no set screws, no shoulders it presses up tight on. They just rely on the press fit. So when I go back together, I will use a little sleeve retainer. Here you can see some stress cracks where it got bent. Don't think that they're anything too much to worry about. I think I'm just going to straighten it up. You can see here how bent everything is on there. So I'll end up making a slug, which you'll see in a little bit. That'll go up tight against there, and then I'll use the puller to straighten everything up. Here's a piece of material I've used for actually a few different jobs. Now I'll just machine the end down to fit the end of this rotor. This lip had some areas where they were kind of rolled over. People got a little rough with it, and I just had to get in there and kind of scrape it to where the slug would fit. Here you can definitely see where everything's cockeyed. A couple of those ears need to or standouts need to be bent over. Those bridges need to be pulled out. Now by having the slug in there, now with the puller, I can just put as much force as I want to it, and it's going to pull it tight right up against that slug. And then I'll loosen it up, rotate the puller, and go again. And I think I got to do like 3 different rotations. Now the material definitely appears to have definitely some copper in it, and it manipulates, actually pretty easy. Thank goodness. Well, here you can see it's not perfect, but it's a whole heck of a lot better than it was. And now with the slug in there, next, now I need to start trying to center it. Center that whole end piece up back with the rotor. Here I grabbed the area that was already machined into jaws, and now I'm just going to drill for an area for my live center to go in. The part running out that's not machined doesn't mean anything. As long as that center's lined up with the area that fits into the rotor, we're good. Now here we got to do a little manipulating. Thank goodness it is soft copper and it doesn't take too much. And basically, if you gain a couple thousandths every time you whack it, you're doing good. If you're wailing on the sucker, then that's probably a little bit harder on the lathe. But as you can see here, I had a ways to go. That clip still had quite a bit of run out, but I was patient and got most of it out. Here we're jumping over to the main cutter head shaft. Already pretty much know where the bends are. I put some shims underneath the block so they don't rock. What I'm doing right now is I put wires right under the center of the bearing. And the reason I do that is I already know it's bent. And when you have that wide of a bearing on a V-block like that, as soon as it walks, it's either going to contact the left side of the bearing or the right, and it's going to raise it up higher, which means it's not going to give you an accurate reading of really how far it's out. Where by having it just sitting on just 2 thin wires will give me a more accurate reading. Here I'm just doing a quick check of the short end while it still has a bearing on it, and it was actually running pretty good. That's the bent end. So at this point now I will be removing the bearings. What I have here is one of my favorite vices of all. I just have a big 3-jaw chuck bolted right to the bench, and I use it for so many things. Works real handy, for this right here. I made this center up years ago with that little shoulder that locks, so no matter how much force you put on it, it can't push back. But anytime you're putting a center in, I always do a skim cut, because you're always going to have, 1/2000 run out if you don't. Here I'm basically just checking to see how accurate the center is on the shaft, which you can see it's not. The center is off, which always makes it a little bit more difficult when you want to spin between centers. Now where I have it chucked up right now is really going to show you how bad the shaft's bent, as you can see right there. I basically have the shaft chucked up in the jaws exactly where the rotor would press on, and my jaws are pretty gosh darn accurate, so that gives you an indication how much run out. As you can see, it's pretty bad. Right there's the area where the majority of the bend is. There's a little tweak in this area. You got the bearing, the nut, a seal, and then the bend, the worst part of the bend. Now here I'm basically just running the live center in, and it's forcing the shaft to run true and straight. But with a high stress area on the other end, what I need to do is get it to a point where it'll run true and straight like that without forcing it over. The one nice thing about a soft shaft that has not been heat treated or hardened in any way is you can heat it up and you can straighten and manipulate it without it affecting the shaft at all. I generally like to do this as my first step, get it running as straight as I can in the lathe, and then I'll do the fine tuning in the press. I got it nice and hot, and right now I'm running the live center right into the end. While I have the live center in, I'm just going to put some more heat on it, bring it back up to red, and then cool her down. This is always a good sign when you can just barely move the live center in and out, and you can just see how true it's running with it. Now here I went outside and grabbed some mysterious metal, and I looked at the end and I thought, all right, it's got a saw cut, so how hard can it be? What I'm doing here is I am going to make a thick wall bushing that's going to heat up and slide on the end of the shaft where the rotor goes. I need to do some straightening in the press, and I do not want the area of the shaft that fits in the rotor to bend at all. So this is going to do two things. It's going to give me some beef to slide on the end of the shaft, and I'm also going to be able to machine an area on it where I can run a dial indicator. Now there's a couple of things that did not go so well. I got my nice perfect size hole there, what I wanted, but I should have machined the outside, got it much closer before I did my final pass. I didn't. So what you see here is I'm micing it, and the center hole, I hit my numbers, that came out good. You'll see the problem here in the next clip. So far with my mystery metal, I was able to drill it. I was able to machine the perfect hole on the inside. I was able to face the end. So what I got to do? Just go and just cut the outside. No big deal. As you can see, it's a little bigger deal. Actually, I'm surprised the cutter was doing as good as it was doing there for a bit, because when I took a file on that area, the file wouldn't even touch it. So the reason I said a little earlier that I should have machined the outside first is what happened, and I figured that would happen when it put that much load on and screwed the cutter up. At that point, it kicked the shaft out a little bit. So what I have to do is go in there and recenter the center hole back up so I can make the outside cut. Now keep in mind that outside little area I'm machining, and the only purpose for that is just to run a dial indicator on it. So it has to run perfectly true to the inside. And in that clip you could see where it was running out a few thousandths. So now that I got the center hole running true again, now all I got to do is just make a little skim cut just on the end of that sleeve. Here it's going to actually show you how far it kicked it out when it broke the cutter. And what we got, about 4 thousandths, it looks like. So now I'll just make a light cut again. My mystery metal did end up costing me extra work. I also had to part it off with my zip wheel. Okay, even though the shaft appeared to be running really nice and true in the lathe, when you actually put it on some blocks and run a dial indicator, you'll find that there's still some issues. I got about 12 thousandths out there. Now the sleeve I'm making, where I press it, I do not want any of that part of the shaft to get bent, because when it initially got bent, it had the rotor pressed on it. So this is just going to replace the rotor and keep that shaft nice and straight, and only let the bend happen where I want it to bend. And here I'll basically heat that up. I want it to heat up and cool and shrink and be a perfect tight fit on that shaft. So I'll just take the torch, heat it up, and tap it on. Okay, I hope I hope I've been clear so far on what this is for. But now that I got that big heavy sleeve on there, it serves two purposes. It gives me a precision machined area where I can tell if the shaft's bent, and it also supports that entire length of the shaft. So when I put it in the press, I only wanted to straighten it right there where it transitions slightly larger. That's where I want the bend to be. Right there is where I want the bend to take place. And this is a very time consuming. Anybody's spent much time straightening shafts, it can be time consuming. Um, thank goodness this is a nice press. It's got a nice gauge on it. And sometimes, you almost have to have a gauge where you can just come up to a certain pressure and just keep increasing and increasing till you finally get it. Otherwise, you chase your tail and you overbend, and definitely need to show a little patience in these operations. Okay, I'm at home in my home shop on my big lathe, and I got the rotor here. This is the area that was bent up pretty bad right here that I needed to get straightened out. What I've done, this actually fits inside the hole on my big chuck, and I machined this sleeve with the 60-degree center that fits inside that lip right there. And what I'll do is I'll just bring the tailstock up to the tip, and get it as close as I can. You know, it's just kind of a, you know, a little like a fan assembly, but when it fell over and got bent, it bent it up pretty good. This is kind of egg-shaped right now, so the best I could do, you know, I dial indicate, you know, 180 out. So if you take this area right here, I'm on 0, kind of rocks a little bit, then I take it all the way over 180, and it's running pretty close. When I come over here, now I'll do the same thing, 180, 180. That one there, you can see about shy, about 1,000. Go all the way over another 180, and it's doing about the same. You know, so I mean, it's when you have something that's not perfectly round, that's about as good as you're gonna get. So there, from there to there, 180, about the same. You go here, 0, go 180, 0. Not gonna get it any better without machining something back to true. Okay. All right, what we got? Let me take this out here. But basically what we have is this here. This bore is where it presses onto the shaft. This does absolutely nothing. It just has a thin plate here. It's already got, when it was bent, it already has a couple little stress cracks in it, which I don't think are going to hurt a thing. It has a plate that just sits inside of this little shoulder with the 3 screws. So I think I'm going to go with it. I think it's going to run good. If I were to machine and try to true everything up, which it was never machined on the outside here, as you can see, that had some machining. This kind of has some rough areas. Like right there, you can see the rough casting there. So they never did do a full machine here. The reason why I don't machine the true stuff up is I do not have the capabilities of balancing everything when it's done. And to me, I can do more damage by machining it true, and if I can't balance it, I've just thrown it out of balance. So I'm going to go with that the way it is and see what happens. Alright, here I'm going to put the bearing back on. It's just got a brass spanner nut. This little area there will fit in that little recess area, so it doesn't contact. The contact area is from that ridge out that contacts the bearing. The way this is designed, this piece fits tight on the inner part of the bearing. This piece tightens up on the inner part. And they kind of rely on that from having it spin on the shaft. But I am a fan of Loctite. I'll put a little bit of Loctite on it. That'll prevent it from ever wanting to spin. And I will also put a little Loctite on the nut. The thing about Loctite, you warm it up and it just comes right off. Here I'll lay the shaft on the bench, and just with a blunt chisel I'll just kind of snug it up with that. That's really not cut for a spanner, so I'll just kind of snug it up with that. It'll be good. Every time I watch a video of me using the press and seeing it wobble, it reminds me I need to drive a couple shims under the legs. Here I got the rotor pressed back on, and it's actually running pretty true. It's got one area where it's a couple thousandths, but when it fell, that rotor's not a big solid chunk of steel, you know, so it doesn't take much to kind of distort it or egg shape it. But overall, I was pretty happy with, you know, with the way it came out. Now, it's easy for me to assume that most people know what the rotor is, but if that's not the case, the rotor is basically the inner shaft of a motor, and then you would have your windings on the outside of it. And basically, that's the rotor. That's half of the electric motor that turns the cutter head. Okay, for anybody that's made it this far into the video, they would probably like to see it run. So my friend picked up the cutter head, actually installed it into Jointer, got it up and running, and sent me a couple videos.
Here we are with a 1951 Northfield 8-inch jointer. last time I ran this thing a while ago, it ran up to 40 hertz and then it started shaking wildly. But now we have a VFD, so we can have some nice speed control. And we've got the head, the cutter head, which is all one piece. It's direct drive, so the motor, rotor, and shaft and spindle, arbor, whatever you want to call it, it's all in there. Don't have the tables on the jointer, as you can see, and don't have the knives or gibs in, but even like that, it was quite wobbly. The whole jointer actually would walk across the floor. So we're going to run this thing and let's see what happens. So I'm going to set the hertz down to a nice safe 10 so that it starts and we get some movement, but we don't blow anything up if things go horribly wrong. Alright, there we go, 12.3. That's fine. So let's hit the forward button. Alright, I can definitely hear the cutter head moving, but the whine is actually coming from this thing. I need to adjust the carrier frequency. But we got our little nickel sitting there. That's handy. So let's crank things up a bit, see what happens. Alright, still pretty nice and quiet. Let's get up to 40 and see what... This is the point when it really started making noise previously. And it's not, I mean, there's no wobble at all. I mean, you can see the dime is just hanging out, or nickel rather. Alright, let's go up to full speed, which is 3450. So this is a shocking improvement over previous. Pretty stoked. Pretty happy. Thanks, Gary.